Hello, guys. Good morning. So we're going to talk about Netdata. Netdata is an open source tool. It's quite popular. How many do you use Netdata here? Oh, OK. How many use other open source observability tools? Prometheus, Grafana, great. Commercial ones? OK, OK. So Netdata is quite a different story compared to any other observability platform. So the first is that it is quite popular. We're not related to CNCF. We're not incubating in CNCF, but still we are the most popular project in the observability category in CNCF. What makes it unique? So Netdata is extremely easy. So you just install it to your servers, and dashboards and alerts are automatically created for you. It's real time. Everything happens per second. It's machine learning across the board. So everything has machine learning for all information, all data you have. And actually, we train machine learning models at the edge on your own data. So it's not some models that we train somewhere else and we pushed. And it's extremely cost efficient compared to anything else. So it has a unique design. What Netdata promises? The first is feel the pulse of your infrastructure. This is the most important. This is how Netdata started, actually. What I needed was a tool to actually feel the pulse of the infrastructure, understand the contentions, the strengths, the weaknesses of the infrastructure. This is how it all started. But today, users that use Netdata enjoy 50 to 90% observability cost reduction, so significantly cheaper compared to anything else. Cheaper to run, cheaper to buy, cheaper everything, less resources, etc. And mainly because of machine learning, half the time for root cause analysis, or even more in many cases. Netdata is what I consider the latest generation of observability tools. So we don't have tracing yet. We are going to add it this year, 2025, actually. But it is all in one. Tracing is missing. Real-time, high fidelity across the board, AI-powered, and extremely cost-efficient. So I consider it the next generation. So this is a typical observability pipeline. This works for everything. Whether you use Prometheus or Grafana, you use Datadog, you use Dynatrace, anything you use, that's the pipeline you have. So you have some servers, and you actually push all the data to some central databases. Metrics databases, logs databases, tracing databases, all the data come here. And then what happens is that you have some logic to actually create dashboards and alerts. A lot happened here. Yesterday, there were some interesting talks that said how you should have use case, the use cases here to actually split the data and not index everything and do some optimization. But this setup, after everything that all the tools do, has certain problems. The biggest problem is that these central databases force certain rules. You have to be careful. So business logic is everywhere. So on your servers, what to collect, on the dashboards, what to visualize, on the alerts, what to alert. Scalability is challenging. A lot of moving parts all over the place. And at the end of the day, expensive. The result, we all know this, low fidelity insights. No one is happy with observability. All people struggle with observability. Very inefficient, usually a development life cycle to actually do the job. Something is missing from observability, you have to go in a development life cycle. Go, put the data in, develop the dashboards, develop the alerts, validate them, verify them, etc. No machine learning in most of the cases, and expensive. So this is what I consider the world happens in the world today. There is either too little observability, there is either too complex observability, or too expensive observability. And the key problem for this is the centralization. Remember, we centralize all the observability data. Now, I have an example here to understand what does this mean, why it's such a big problem. If you collect 3,000 metrics every second, so this is 3K samples per second, you are doing 450 times more work compared to a system that collects 100 metrics every 15 seconds. 450 times more work. And that's the problem of the central databases. So how we solve this? That was the fundamental problem that on observability that we tried to solve. Then we solved a lot more, but let's see them. Netdata keeps the data at the edge. So instead of moving all the data to some central databases, what we say, hey, wait a moment. These data are a lot. We collect them every second. And we want them all indexed, all analyzed. They have machine learning for everything. Why move the data in the first place? Let's push the code to the edge. Instead of moving the data centrally, move the code there. When you move the code there, interesting things happen. The first thing is that the data set that you can have at the edge is small. Even if it is 10,000 metrics, 20,000 metrics per second, a lot of logs, etc., still is something that is generated at the edge. So it's a small data set, and everything can be a lot more efficient. The next thing that we did is that mainly because you may have ephemeral nodes, etc., so nodes that may vanish at any given point, we allowed centralizing data, but this time you can have as many little centralization points as you need. So it looks like this. So you install the data on all your infrastructure. You understand that the moment you do this, all the central stuff disappears. Then you can have mini centralization points. So when you have ephemeral nodes or Kubernetes clusters or something that will not be there forever, you can have the same software, it's the same software, that can act as a parent. But you can have as many of them as you want. And then we have this thin layer. Netdata Cloud is a proxy. It actually gets requests from users and distributes them to your infrastructure. It doesn't store any data itself. It's just the head end of a database without storing the data. And of course, if you have parents, the data cloud talks to the parents, not to your infrastructure. Now, this is the pipeline inside every agent. This is for logs, this is for metrics. For metrics, as you see, the data collects data, detects anomalies in real time, stores them in its own database. So there is a database on the node. Stores them in the database, then learns, this machine learning, learns to feed the anomaly detection. It's the health engine, so it checks and transitions alerts and sends notifications. Query engine, the normal query engine that we know, that all observability platforms have, but Netdata has also a scoring engine. The scoring engine allows Netdata to check all the metrics against some algorithm or some pattern and score them. This is unique. We're going to see how it's used. Export the metrics so you can push them to Prometheus, to whatever you want, and stream them to remote Netdata. So this is how parents are built. It gets connected here. Okay? For logs, we rely on systemd journal. So for logs go to the journal D API, they come to systemd journal. Systemd journal, we have it all. We use it even if we don't like it. It's there, in all systems. So what we said is that why we need something more? Why we need something else? Why to move the data out of the node? So let's put all the logs in systemd journal. For this, we created log2journal. It's a tool that converts text files, JSON files, logFMD files into the journal D API. The same way, Netdata queries journal files and creates dashboards. And of course, systemd journal has all the methodologies to actually create centralization points. So you can still have distributed or centralized to the degree you want. Now, you understand that this is an agent that does a lot. You install an agent that is fat compared to anyone else, any other observability platform. So the most common concern is, come on, the agent is going to be heavy. It's going to be a lot. Machine learning at the edge, so they will. Accident. we're back. Sorry, guys. Something's happening. Okay, I have it. I'm totally wired. Machine learning at the edge, So it's going to be heavy. Come on, it's going to do a lot of stuff. No is the answer. I have the next slide. I will go a little bit back and forth. We compared the agents of all these. So look what happens. Granularity. Netdata is per second is the same as Instana. Instana has a very small retention, though, and very few metrics. Netdata, in technology coverage, there is a full analysis here if you want to scan this. You can see the full comparison. So the technology coverage, we are excellent compared to anyone else. A lot more metrics, a lot more information, a lot more of everything. You see the CPU usage of Netdata agent. Only the Grafana agent with per minute data collection is better than Netdata. Look at the RAM. There is no comparison. Of course, we need some storage. Of course. We need 3 gigabytes on disk to actually provide you 2 weeks per second, 3 months per minute, and more than a year per hour, this shared database. So the first thing is that the agent will not be heavy. Queries will influence production systems. No. Why? Because all the data set that the node has is a very, very tiny thing. So most of our queries are sub-millisecond. They bump like this, they end. So actually they don't. Queries will be slower. No, they are not slower. Why? Because the aggregate horsepower you have. Do you remember this slide? The aggregate horsepower you have when you do a query here, can you imagine it? How many machines did a tiny thing of work to actually respond to you? So all of them responded. We aggregated the data here and we presented to them. This is actually faster than anything else. And will require more bandwidth. As a lot of speakers said yesterday, the bandwidth for observability data are almost never viewed. So you query, you collect them, you ingest them, you index them, you store them, you retain them, but come on, you see only a fraction of the data that are there. So what Netdata does is that it uses bandwidth only for what you see. For the others are just local on the machine. Nothing happens, nothing is moving. No data on the wire. So to understand how optimized Netdata is, we stress tested a Netdata parent versus Prometheus for 2.7 million metrics per second. So the same metrics were pushed to the 2 systems at the same time. And this is what we found. We beat Prometheus everywhere. You see 1/3 less CPU, half the memory, 98% less disk I/O. The disk footprint is amazing. Prometheus managed to give in 3 terabytes 7 days per second. We had 10 days per second, 43 days per minute, and more than a year per hour. Netdata uses half a byte per sample on the high resolution tier on disk. Half a byte. University of Amsterdam in 2023 did a research on the impact of monitoring systems on container-based systems, and they found that the Netdata is the most efficient tool and excels in terms of performance impact on containers. So I have 5 challenges to tell you. The first was the fidelity. How we solve fidelity. So with Netdata, what we say is, get all the data, move them in. It doesn't matter. In high resolution, everything. The more you have, the better it is. And then we had 5 challenges to solve. The first is, come on, we all have the same physical or virtual hardware. So you may say, my infrastructure is different than yours. It is. But if you look closer, we use the same operating systems, or similar. The same application servers. It's a database, it's a Postgres, my Postgres, your Postgres. It's a Redis, it's a message bus, a Kafka, or I don't know, a Pulsar or something. So we all use the same components. Now, imagine the waste of resources at a global scale, each one of us configuring what is Postgres and how it should be monitored. It's a waste at global scale. Everyone is doing it. Everyone is doing it. What we say with Netdata is that Netdata knows how to monitor the components. So it doesn't matter how many components you have, Netdata knows them. So the moment you install it, you don't need to do anything else. And what we invented, what we wanted is the visualization to be fully automated. So in a data visualization, it's an algorithm. It's not pre-configured templates of charts. So templates are fully, dashboards are fully dynamic and reflect what you have as data. So each data is unique. All the charts are visualized. Everything, machine learning across the board for your data set. How we achieved that? We invented the needle framework. This is a framework to actually say what is a node, what is an instance, what is dimensions, and what is the labels. All of them are labels at the end of the day on the same metrics. But it's a framework to actually allow us have an algorithm to create dashboards. So, we did the same for alerts. So alerts are pre-configured, of course, with rolling windows and the like, so we don't use fixed thresholds in the stock alerts that we ship with Netdata. But the idea is that alerts are attached to components. So we create an alert for a network interface, and all network interfaces get it. For a Postgres server, all Postgres servers get it. One table of a Postgres server, then all tables of Postgres servers get it. So the idea is that we have alerts that are watchdogs on components, component by component. Now, how to get rid of the query language? That's a big problem. The learning curve of observability goes through learning a query language. Can we get rid of it? We did, actually. So, and this was another problem that we had. So you install Netdata, thousands of metrics, or visualize with alerts, and then you see a dashboard. And you see all the metrics for the first time. For the first time, you never experienced it before. How can we make you grasp the information you see? How we can make the chart, what we should add on a chart to actually allow you really understand what do you see? This is a chart, a normal chart, as most platforms. There is an info button. Oh, it's not, there is a ribbon there that is not visible. Sorry for that. So there's an info button, you press it, you get some information. And here, there is the needle control. So this says nodes, applications, instances. This thing changes per chart. In this case, it's context switches of CPU, context switches of processes, of applications. These are the dimensions, these are the labels. There is an anomaly ribbon here. Sorry, guys, it's not very well visible. There is an anomaly rate ribbon here. So this shows the anomaly across time for the entire data set. There is an info ribbon here, which shows exceptions. Data are missing. You see this? Data are missing here. And there is also aggregation functions and grouping functions on every chart, Now, if you open I just clicked nodes there. And then you have this view. This says, OK, these are your 7 nodes. These are how many instances, components come from this node. This is how many metrics, time series come from this node. This is the volume contribution of each node on the chart. So this node, if I remove it, I will lose 17% of the chart, of the volume of the chart. This is the anomaly rate of every node, alerts, if there are alerts on this chart, and the actually database values, minimum, average, and maximum of the database values that it encountered while doing the query. Now, this works for nodes, instances, dimensions, and labels. So you can see this per label, the volume contribution of a label, the anomaly rate of a label. And then, of course, when clicking the grouping, you can select anything that you want here. There are ticks here. So you can select anything you want, and the data will turn the dimensions of the chart to whatever you said. In this case, dimension and device type. And you see here, it says reads physical, reads virtual, writes physical, writes virtual. The info ribbon is for you to understand if data are missing. Now, this is one important thing about Netdata. Netdata works on a bit, every second, on a bit. It runs with the lowest priority on your systems. So what happens when it misses a bit? That's a big deal. If Netdata misses a bit, your infrastructure has a problem, for sure. Something doesn't work. What all the other observability platforms do? They connect the dots. So they miss a bit, or it fluctuates, the bit fluctuates, and they just connect the dot on all the visualization. This happens on every observability platform. Netdata is the only tool that if it misses a bit, there is a gap, and you know it. This is extremely important for if you use cloud providers, because cloud infrastructure is not linear, it's virtual. It's something that is subject to maintenance, to operations, to a lot of stuff by someone else. The hardware is not there for you all the time. It may not be. So all these calculations that we saw happen in one go. The third challenge, machine learning. In 2019, Dot Underwood from Google gave this speech. He said, all of our ML ideas are bad. So what Dot did is the following. He went to SREs, to Google SREs, and said, guys, what do you want AI and ML to do for you? He gathered all the ideas, and he tried to do them. And nothing worked. So he gave this speech, all of our ML ideas are bad. A lot of people think that because of this speech, ML cannot do anything for observability. This is wrong. So what can ML do for us? ML is the simplest way to actually model the behavior of our metrics. There is no simpler way to do it. You feed the data to an ML model, and you actually have an algorithm that can say to you if the next sample that you are going to take is an outlier or not. Is this an expected value or not? So this is the simplest. There is nothing simpler than this. So because this detects patterns, detects periods, and detects everything. Now, what we did is that we ran this thing. We ran a k-means algorithm where it is totally unsupervised. You don't need to configure anything. It learns the last few days of all your data. And then during every second during data collection, we ask the machine learning model, is this an outlier or not? I collected this value. Is this an outlier or not? And it gives us either true or false, of course, with some thresholds, etc. What do we do with this? We store it in the database. So every sample in the data, in the database, has a bit that says if it was anomalous when it was collected or not. Now, this is interesting because now we can see that we can query for the anomaly rate across any period. We can say from that time to that time, give me the anomaly rate of that thing. Or give me the overall anomaly rate of the whole server. Now, okay, this is a summary. I said it, we did a lot of work about make it real time, make it lightweight, stored in the database. I will go quickly through them. A lot of models because we want it in rolling, in a rolling fashion, lightweight. So what it can detect? This is observations. We didn't do anything to do this. We observe that the machine learning model detects this. So it will detect extremes. It will detect missing periods. It will detect strange multivariant patterns. This is the terminology of the data scientists. Strange drifts. You see there that it goes up for some reason. Even strange step. that something that didn't happen before, it would step. Why? What's that? So these are some of the anomalies that it detects. Now, this is a data dashboard. There is a table of contents here where all your applications and charts and whatever you have are related. There is a button there. Where is it? I don't see it. Sorry, guys. This button, it's there. I think it's there. It's this button. So when you press it, what happens is that Netdata uses the scoring engine now and gives to the scoring engine the time frame from the daytime picker, and it says, you know what, score all the metrics according to this, to their anomaly rate. And then annotates all the sections with the anomaly rate. So you can see what is interesting. What is interesting now? You can go back post-mortem and say, okay, that's the time frame that the incident happened. What was anomalous? What was interesting in that time frame? But we didn't stop there. So we calculate host anomaly rate. What we observe, guys, is better on this chart. On this chart, every line is a node. And what we observe, and the y-axis is how the percentage of the dimensions of the metrics of a server that got anomalous together, concurrently. So what we realized is that anomalies happen in clusters. It's not one thing. It's not an anomaly on a dimension. They happen in clusters. And then what we realized is that either it is like this, a lot of nodes get anomalous at the same time, or it is like this. One got anomalous, and after some time, other nodes got anomalous. So we created a tool, we call it Anomaly Advisor, where you highlight, this is highlighted, it cannot show it, sorry for that. You highlight an area, and actually you get an ordered list of what is anomalous, what is most relevant. Now, look what we changed with this. How do you troubleshoot? How do you usually troubleshoot in observability? You have a problem. You see a dive on your sales or transactions or whatever. And what do? You start speculating. All tools. Oh, what if it is the database? What if it is the network? What if it is the storage? What if it is the web server? The database server? And you start validating or dropping these assumptions, right? This is how we all do it. What we change with this tool? You go to the tool and you say, you highlight the area, it gives you the results, and your aha moment is within the top results. So suddenly you say, what? The database did that? The network did that? The storage did that? You get it? Completely flipped. And this is amazing for root cause analysis because it correlates anything across anything if they have the same similar anomaly patterns. Anything across anything. Even if you don't know that something is correlated, it will find it. So it's totally unsupervised. I skipped it because I don't have time, guys. Logs, challenge, I have two more, this and another one, logs. What we did is that we used systemd journal. We submitted patches to systemd journal to make it 14 times faster. This is how it looks at the end of the day. It's a beast. This is actually 15 million log entries in your view. There are a ton of optimizations. Actually, what we say is, come on, guys, keep your logs in systemd journal. Systemd journal, you have it, you use it already. Just start Netdata on a systemd journal system, and you don't need to configure anything. You have your logs, your explorer, everything you need. This is, we started with this year. We still add alerts. There are no alerts for logs currently. And also a lot of people ask us to extract metrics from logs. So as logs are generated, to extract metrics. So we're adding these features now. And we added all the tools, log to journal, to actually do the job, push everything into systemd journal. The last thing is the following. There are more in observability than metrics, log, and traces. What if I want to explore all the network connections of a server? The slow queries of Postgres. the process tree. What do you do? Oh, go to the console. What we said with Netdata is, no, guys, every plugin that we have exposes functions. So the Postgres collector of Netdata says, hey, you know what? I expose a function, I call it slow queries. Whenever you call it, I am going to give you the list of slow queries. The same with network connections. Hey, I am the network viewer plugin. I expose a function, I call it network connections. Whenever you call it, I'm going to give you back all the network connections of the system. So what we did is, via Netdata routing, this is connections between parent and children and the likes, we route these requests to actually reach the origin plugin that exposes the function and present it to you. This way, for example, you can see all the network connections of a system, live. This is live information. You see the chart moving. Functions, so another mission accomplished. This is how we make money, guys. We sell Netdata Cloud, subscriptions to Netdata Cloud, either on-prem or... so everything is open source. The entire Netdata, machine learning, everything. If you use the parents by themselves, everything is open source. You can use it free. What we sell is this thing: horizontal scalability, role-based access control, access from anywhere, mobile app for notifications, and persistent customizations and dynamic configuration. Thank you very much.
Thank you so much. Also for the energy, I love it. I feel very pumped. It was very, very great. No, really, seriously. Especially in the morning. So are there any questions?
Yes.
There we go.
I think it was on slide number 18. So first of all, great presentation. I really, really enjoyed it. So first of all,
thank you very much.
On page number 18, I think you showed the schematic of the setup and pointed out that the data is stored on the edge. Yes, exactly this page I mean. And my question is, on this page, for example, you have the machine learning component. You have your store time series database on the left side. Then you have your learn functionality and your check functionality. And my question is, my understanding is now, if I use this distributed system and have, for example, a second server or a second infrastructure that is handled by this Netdata agent, then this would be its own subsection. It would have in its own...
So every Netdata that you install runs this, all of it. This is on each of your Netdata.
Yes.
Each.
And my question would be, in this case, is it possible that, for example, the check or the machine learning would use data from different sources?
This is what happens here. So when you delegate this from here to there, this is between Netdata agents now.
Okay.
Okay? So all this can shut down on the child.
Yeah.
And you run everything on the parent.
Okay.
So it's up to you to delegate what you want.
I see.
Look, it depends how much you want to scale the parent. If you want to put a few thousand machines on a parent, then come on, let's train ML on the children and push the models to the parent with this logic.
Yeah.
But because if you train on the parent, I'm going to tell you, come on, you need a lot of cores.
Yeah.
You're going to need, I don't know, 40 cores to actually do ML for all of them. Okay? Yeah. So this is we have users that use the check for automation. So here, Netdata allows you to run a script. When the alert triggers, run the script. This means that you can do automations here on the child. So it depends what you want. What we say is we give you the flexibility to either do it centrally or distribute it or whatever you want.
Yeah.
So it's up to you to configure it to select what you want. On the child, on the parent. Run ML on the parent, health check on the child because you need the automation. Or opposite, whatever you want.
Okay, thank you so much. Perfectly answered.
So in this case, this is the case. All these may delegate all their functions here. On the other, this may do only increased retention. Nothing else. And this may also run in RAM mode, so nothing on the disk. High speed, everything disabled, push the data.
Any further questions? There we go.
Yeah, great presentation. Thank you. Sorry to bring that question around. So is Netdata Cloud like a free tier?
Of course. So Netdata Cloud is available as a SaaS or on-prem. So you can have it on-prem. It's a Kubernetes cluster, of course, but you can have it on-prem. And there is also a community here that's free to use. Okay? But it's not required. What we did with Netdata, let's take this setup. This has a dashboard, this has a dashboard, this has a dashboard. Guess what? It's the same dashboard. What changes is the scope of the data set. Here, the entire data set is available. Here, this data set is available. Here, only that node is available. So the same dashboard works everywhere. That is fully automated, it's an AI algorithm, okay? It's the same thing.
So yeah, just to like conclude, is it possible to use Netdata Cloud like a single pane of glass type of observability?
Yes, of course, that's the idea. That's
yeah,
what people do, yes, of course.
Okay. Yeah.
Because you can have with the routing that I said about functions, when you go here and you ask if this is a Postgres server and you ask the slow queries of Postgres, the query will go there, get the slow data, the slow queries from the Postgres and return it back to you. That's the beauty. So we simplified the entire thing for you.
So I have another question for the GUI or visualization. The dashboards are only available at the top, or does each node have some kind of
As I said,
GUI?
the dashboard, the same dashboard, is available here, here, and here. Okay. The same dashboard. What changes is what data it has. At this level, it has all of it.
Yeah, sure.
At this level, it has this. At this level, it has itself. But the dashboard is the same.
Okay, thank you.
Just a clarification. So if the data is only stored on the edge or on the parent, what happens if one of these
No,
go down?
look what happens. Data are stored here by default. This happens by default. Now you have the option to disable that thing, the storage here, completely. The child will run in RAM mode, have a tiny database in RAM, and push all the metrics here. Here you can have a different retention, different alerts, different stuff. And this actually stores your data when you do it like that. You can do replication. Oh, keep the data at the child, keep it at the parent. You can do, a lot of people do, they disable everything on the children. The production systems are just collectors, and they have a parent next to them or a parent cluster next to them that actually does all the job. You get it? So it depends on your use case. What we say is that we don't require centralization points. It's up to you to have as many as you need, due to replication, due to high availability, due to whatever. And it's not necessary everything to be homogeneous. So this node is a replica, has some retention on disk. This node doesn't. It's up to you. Do whatever you want.
Yeah. Thanks. All right.
Probably I move my head a lot or something.
You mentioned application VMs. What about switches and routers?
Yes, everything, of course. Netdata has 800 plugins, integration plugins. What we do is that mainly because we have these functions and the likes, we want to have our native plugins, but we support open metrics, we support SNMP, we support StatsD. Now we're developing open telemetry. We are about to release it next month. So it's an open thing. Don't think it's not proprietary. You can export everything. You can import from anything. It's an open platform. The open source philosophy is throughout it.
All right.
Thank you for a great talk. And what does it do in terms of Windows support? I know it's probably a minority here,
We released Windows support for the entire thing this month. So
perfect.
go get it. The agent, all of it runs. We ported everything, yes.
In terms of Kubernetes clusters, on what do you install it? Or per cluster, per node?
You install it per node. Netdata talks directly to the kernel, so we don't rely on cAdvisor and all these things to actually get container metrics and the likes. We collect them directly from the kernel. Actually, this happens for all container technologies. So we monitor LXC, we monitor Docker, it doesn't matter what it is, Proxmox servers, whatever. Or if it is using container technology in Linux, we talk to the kernel, we collect all the data. This makes us also per second, and you need one installation per node.
One follow-up question. You have probably the same application, so the same kind of component on several clusters. So I would say I would like to have machine learning for this component somewhere centralized, but I have several different applications per cluster. So can you split up the data to several parents?
So you can run machine learning here or you can run machine learning there. This is actually an infinite loop. If you want, you can have grandparents, child, parent, grandparent, grand-grandparent. You can have as many as you want. So if you don't want to bother with ML on the edge systems or whatever, you can have a grandparent actually do ML for you.
Yeah, but I want to have one parent for application A and another parent for application B.
No, you cannot have it today. It's doable for us. It's doable. The whole point was that, let's take, guys, a quick example. You have two database servers, A and B. Same hardware, same software, same data. Everything is the same. Can I train a machine learning on A and use it on B? Can I do it? No, because it depends on the workload. Do they get the same workload? If they don't, even slightly, the machine learning model of A will be invalid, full of false positives on B. So what we do is that we train machine learning models on the data that are actually happening. What you ask, I understand, is a combined model. So to combine the two and have one model. We don't do it yet. It's doable. So it's mostly a matter of configuration of how this goes. Other people ask to remember, instead of remembering the last few days, to remember Mondays, Tuesdays, or Black Fridays, or to do stuff like that. So all these are doable, but we don't have the configuration management to actually do it yet.
Unfortunately, we're out of time.
Okay,
but
thank you very much, guys.
Thank you so much.
Thank you very much, guys.